Okay, another decimal one here. So we will make sure we do the division before anything else. So we could start off with 1 minus 0.6, and then adding. We had a problem similar to this before. So you can think 3 divided by 3 is, which is 1. So 0.3 divided by 3 is 0.1. Okay, dividing 3/10 into 3, that's 1/10 each. That's another way to think of it. So 0.1. Now we have subtraction and addition, and if you recall, they're on the same level when it comes to the order of operations. So we'll just go from left to right, meaning let's do the subtraction first. And with decimals, I think it works well to think about money. If you have $1, $1 can be written like this, and then you buy something or you take away 60 cents, right? That's zero. That's the same thing as you're subtracting off 0.60. And you might be able to do that intuitively, but that ends up being 40 cents, right? Or 0.4. We don't actually need this zero at the end. So that becomes 0.4 plus 0.1. And I feel like that one's pretty straightforward. To add those together is 0.5 or a half. Another level 4 problem. Okay, order of operations tell us to do stuff inside the parentheses first, remember. So even though this is multiplication on the outside, and multiplication would come before the subtraction you see in here, since the subtraction's inside the parentheses, we're actually going to do that before this multiplication. So this timesing of 6 is going to be the last thing we do. But inside here, we're actually going to divide first. So we divide before we do anything else. So yeah, what we're actually going to do first, that's not a super easy division. 0.3 divided by 0.5. It might help to, so one thing you can do is you can move the decimal, which is like multiplying by 10, but whatever you do to the one number, you also have to do to the other number. So it's nice to maybe think of them as both whole numbers then. 3 divided by 5, which still isn't like super easy to divide. So 3 divided by 5, how many times does 3 go into 5? Well, it doesn't go in at all, any whole time. So this is one way you can do it, long division, if you recall. So 3 goes into 5. Oh, sorry. I'm writing that the wrong way. So we've got 3 divided by 5. That's not super easy. There's a couple different ways you could go about this. Since we're working with decimals, it'd be nice to get this into a decimal form. And the way you can do this the long way is 3. How many times does 5 go into 3? Well, it doesn't go in at all. So then you have to do that move where you make a decimal and add the 0, and then you think of how many times can 5 go into 30, and it's 6 times. And that works out nicely, actually, when you subtract them. So it's 0.6. Okay, and you can always check that with a calculator. That's fine too. So that part became 0.6. So it's 6 times 0.1 minus 0.6. And then we subtract that. So that's a number line thing, if you will. That's how I like to think of these, because this is going to, well, the reason why I would bring up the number line, because this isn't super easy subtraction, because I know I'm going to go into negatives. So if you're ever unsure, and you don't have to go by ones on a number line, in this case, I'm going to go by 0.1. So this would be 0, negative 0.1, negative 0.2, 3, 4, 5, and so, and actually I know that that's as far as I need to go, because if you remember the rule, subtraction means go to the left. So we're going to go left 0.6. So here's where we're starting. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 gives us to negative 0.5 there. So we have 6 times negative 0.5. And what I like to think here is I multiply the whole numbers that I see. So 6 and 5. And then whatever answer I get from there, I have to move the decimal left one, because right now I'm kind of thinking of it as the 5 with the decimal to the right. So to compensate that afterward, we'll have to move it back left. So 6 times 5, which is 30 with the decimal here. But then, like I was just saying, move that back. So it's actually, so 6 times 0.5 is 3.0, or just 3. But we weren't actually multiplying 6 times 0.5, we're multiplying 6 times negative 0.5. And when you're multiplying two numbers and one is positive, one is negative, your answer is negative. If they're both positive, or if they're both negative, then you get positive answers. But so in this case, this is going to end up equaling negative 3, which just right up here, negative 3. And these problems, calculators can come in real in handy, but it's good practice to try to do it. See if you can do it by hand and on your own, and then check yourself with the calculator. So, okay, a level 5 problem. Now these are beyond the 80 level requirement, the 80 smart score requirement. But for those of you who want to give these a shot, I want to be able to show you some examples. So same kind of thing. Just we got a lot of negatives here. We do division and multiplication first. There's 2 of them, so we do the one that's further left. So this is what we're going to do first. So the negative 1/2 stays. Now, before I actually calculate this, remember we're going to switch this to multiplying by the reciprocal. So it's still going to be plus negative 3/4, but now I'm going to change it to multiplying. And the reciprocal of negative 1/3 is going to be negative 3/1. So you flip it like so. And then we'll still do, okay, I guess they're using an x for times. I tend to use the dot more. So multiplying fractions is actually not too bad. Multiply tops, multiply bottoms. So it's still negative 1/2. Negative 3 times another negative 3 is a positive 9. We were just talking about that. 2 negatives make a positive with multiplying. 4 times 1 is 4. And we're still multiplying on this side. So among these things, we want to multiply before we do the addition. Continue that over here. So it's still equal negative 1/2. Multiply tops to tops, bottom to bottom. So 9 times negative 3. Oops, it's a plus sign. 9 times negative 3 is negative 27. And 4 times 5 is 20. All right, so negative 1/2 plus negative 27/20. All right, well, we got to have common denominators when we're adding and subtracting fractions. So we've done this a few times already in this lesson. Trying to get that 2 to become a 20, I'm going to multiply by 10. I can leave the other side because it's already got a 20 in the denominator. So that'll become negative 10/20, and add that to negative 27/20. Okay, we're adding negatives. Whenever you're unsure here, go back to that number line, okay? So let's say this is negative 10. Okay, I'm adding, so I think, okay, I'm going to go to the right. I'm going to go to the right, but so I would think going right 27, which would be going this way. But since it's a negative 27, we go the opposite way. So we're going to go 27 to the left. And And you could draw out every little tick mark, but I just know, okay, if I'm here and I go 27 this direction, where am I going to end up? So I'm basically adding, and remember, negative numbers get bigger as you go left. So I'm adding negative 27, or sorry, I'm adding 27 to 10 is basically what we're doing because we're getting bigger. That'll get us to negative 37. So another thing that you can do if you're remembering is, hey, whenever I'm adding negatives together, they become a greater negative. So just because like 10 plus 27 is 37, therefore, when you add the two negative versions, they make negative 37. So that's another way to reason through it. But if you're ever in doubt, I would go back to the number line because that's where the rules really are based from. So in this problem, you could leave it like that or make it a mixed number. Negative or 20 goes into negative 37 negative 1 whole times. And when you do that, there'd be 17 left over. So 17 out of 20. So either of those answers are acceptable. No reducing needed on that one. And there's one more level, and these fractions can get quite complicated. So then they're really pushing the limits here. So there's parentheses. So let's focus on that. And there's two separate parentheses. So I think we can do this and this at the same time. So first off, mixed numbers, okay? So these are mixed numbers. And I would prefer to have that in an improper fraction form when I'm doing this. There's a couple different ways of doing it. And actually, now that I think about it, So looking at the numbers, we have 5 3/5, which is actually pretty close to 6, is what I'm thinking. So it's like you have 5 3/5. So let's say these are 1, 2, 3, 4, 5, and then, a one that's a little bit shorter. It's a 3/5. And these are all positive. Right, this is all positive values. Okay, this is like 1, 2, 3, and these are all can be broken up. These are all wholes, I guess. And this is 3 out of, there'd be 2 more to make a whole. So that's 5 3/5. But then you have 6 wholes, and I'm using red for negatives. So that's -5, and you have -6. So this is all negative. And when you do this, every negative cancels out with a positive. So this cancels, 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 cancels. And now we have to start thinking a little more. So these 3/5 should cancel out with 3/5 in the red down here. So if I broke this into fifths, 1, 2, 3, 4, 5 little segments, then 3 of these, so 1/5, 1/5 cancel because there's a positive fifth on the top and a negative fifth on the bottom. A positive fifth cancels out with a negative fifth, and one more positive fifth cancels out with one more negative fifth. And you can't do any more canceling because we ran out of positives, right? All the positives were canceled out. So we're left with 2/5 and a whole, and they're all in the red here. They're all negative. So that's -1 and 2/5, if that makes sense. So that's another way to go about this. So that all that stuff in the front is -1 and 2/5. We might still want to make that into an improper fraction later, but for now we'll just leave it a mixed number, and that's going to divide by. Okay. Now we have to do this one that's inside the parentheses. So Okay, so we can do a similar thing as we did that last one, where we drew it out, because -4.5 is really close to the same size as -4, but we're subtracting. So thinking about that number line thing, and actually maybe we could do a number line on this one. Let's see, what would that look like? Well, maybe I'll draw a little more carefully. So -4.5 is where we're starting. And maybe I'll go, since we've got halves involved here, I'll make whole numbers a little longer. So if that's -4.5, this would be -4. Then this would be -3.5, -3, -2.5, -2, -1.5, -1, -0.5, 0. Going this way, it'd be -5, -5.5, -6. So notice I'm making all the whole, or the integer ones. Integers can be negative. That's why I say integers, because we have lots of negatives here. They're like the bigger ones. But every little tick mark represents a half. So in this problem, I would start at -4.5, and I'm subtracting, so we're thinking left. Subtract means going left, so I would be going left, but since we're subtracting a negative number, I go the opposite direction, so I'm going to go right 4. And I'm going right 4 wholes. So going right 1 from -4.5, I go actually to the next halfway mark. That's 1, 2, 3, 4. So notice that we're now here, and that is -1/2. That's a -1/2 right there. And that's what that becomes. So now it's divided by -1/2. And I'm keeping this in parentheses because we still have that exponent of 3. Okay. So this is definitely a level 6 problem, because now we've got to do a third power of -1/2, which actually is not, and that's the next move, because exponents come before division, right? Because there's also that division there. But exponents come first. Okay, so a third power means multiply that same thing by itself 3 times. Maybe we'll do that off to the side as well. -1/2 to the third power just means -1/2 times -1/2 times -1/2. Again, you multiply the tops. So -1 times -1 times -1 is -1, right? Because the first two -1s make +1. Multiplied by another -1, you get -1. And 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8. So -1/8 is what that becomes. Whew, okay, and at the same time, let's go ahead and convert this mixed number into an improper fraction. The way you do that is you take the whole number, you multiply it with the denominator, so that's going to be 5 or -5, and then you increase that by 2. And I know with negatives it's kind of confusing, so technically you're decreasing it by 2, but I guess maybe it might be easier to ignore the negative and take 1 times 5 is 5, plus 2 is 7. And then that's going to be 7 over 5. So it's 7 over 5. But then now we have to remember, oh, hey, actually it is a negative number, so it's -7 over 5. Divided by that answer we got earlier, -1/8. Whew, all right. And dividing fractions is the same thing as multiplying by the reciprocal. So that's -7 over 5 times, and I'm going to flip that, 8 over -1. And at this point, we can multiply the tops and multiply the bottoms. And let's see, what are we going to get? So -7 times 8 is -56, and 5 times -1 is -5. Okay, and when you have negative over negative, that's because, remember, a fraction is a division problem. So when you divide two negatives, you actually get a positive. So you can think of that as 56 fifths. which could be your final answer as a improper fraction. As a mixed number, 5 goes into 56 11 times, because 5 times 11 is 55. And then 55 goes into 56 with just one remaining, so that's 1/5 at the end.